Hi everyone, today we're going to do solving radical equations. I gave you the notes in class so that all you have to do is fill in where we do the examples together. So make sure you have them in front of you. If you don't, pause the video, go get them, and come back. Okay, now that you have your notes in front of you, there are two methods to solving radical equations. The top method will be the algebraic method, and this is the method that we're going to use today on the video. The alternative method is using your graphing calculator. When we are done with the video, if you'd like to play around with that method on your own in your graphing calculator, go right ahead. But tomorrow we'll go over that method more clearly in class. All right, let's go up to the top to the algebraic method. First step says we need to isolate the radical, very similar to how we isolated the absolute value when we did absolute value equations. Then we're going to square both sides of the equation so we can get rid of the radical, because remember, squaring and square root cancel each other out. We're going to solve for the variable and then check our solutions into the original equations. Okay, let's go on to example number 1. If you take a look at example number 1, you have to ask yourself, is the radical isolated? And yes, it is. So in order to get rid of the radical, we're going to square both sides. So we're going to square the right side, or the left side of the equation and the right side. So we'll end up with x minus 2 equals 25. We're going to solve for x by adding 2 to both sides, and x is going to equal 27. We're going to take our answer and plug it back into the original equation. 27 minus 2 is 25. The square root of 25 is 5, so it checks. So my answer is 27. All right, let's go on to number 2. In number 2, if you take a look at it, the radical is not isolated, so we have to move the 7 to the other side. So we're going to subtract 7 on both sides. And we're going to end up with the square root of 2y minus 1 equals a negative 3. We're now going to eliminate the radical by squaring both sides, because square root and squaring cancel each other out. So on the left we have 2y minus 1. On the right, a negative 3 times a negative 3 is a positive 9. So we're going to solve for y by adding 1 to both sides. 2y equals 10. We're going to divide each side by 2. Y comes out to be 5. We're then going to plug it back into the original and check to see if it works. Well, let's see. 2 times 5 is 10. 10 minus 1 is 9. Square root of 9 is 3. 3 and 7 is 10. It doesn't equal 4. So we're going to have to reject this answer, and he's the only answer we have. So our answer will be a empty set. And that happens sometimes. All right, let's go on to another example. If you take a look at number 3, we don't have the radical isolated, and it's on the right side this time, and that's okay. We should be okay whether it's on the right side or the left side. So we're going to get rid of the 1 by subtracting 1 on both sides, because the 1 is a positive, so we have to move it to the other side. So we have x minus 1 equals the positive of, and we don't really need the plus in front, of x plus 5. Square root of x plus 5, that is. All right, so now we're going to eliminate the radical by squaring both sides. The right side is squaring a binomial, so we basically have x plus 1, oops, I'm sorry, not plus 1. We have x minus 1 times x minus 1. And on the right side, squaring and square root cancel each other out, so we have x plus 5. So in order to solve the left side here, we're going to have to do FOIL to x minus 1 times x minus 1. So we're going to have first, which is x squared, outer minus x, inner minus x, last plus 1, equals x plus 5. Okay, I'm going to neaten up the left side and get x squared minus 2x plus 1 equals x plus 5. Now we have a squaring. The only way you know how to solve a squaring is to get one side equal to 0. So it looks like the right side would be our best guy to get equal to 0. So we're going to have to subtract an x on both sides and a 5 on both sides. All right, I'm running out of room, so I'm going to bring it up here. Let's see what we have. X squared. Negative 2x minus x is a minus 3x. Positive 1 minus 5 is a negative 4 equals 0. All right, can I GCF? No, but I can go to two binomials. It's an x and an x. Factors of a negative 4, that'll give me a negative 3, minus 4, and a plus 1, t-bar. x equals a positive 4, x equals a negative 1. So now I have two answers that I need to check. So I want you to pause the video and check both answers and see if they both work, or if one only works, or if neither of them works. Okay, hopefully you found out that 4 works and negative 1 rejects. So the only answer you have is x equals 4. All right, let's go down to example number 4 now. In example number 4, the radical is not isolated, so we have a couple of things to get rid of. We have a multiplying 2 and an adding 8. So according to algebra, we need to eliminate addition and subtraction first. So we're going to get rid of 8 by subtracting it on both sides. So I have 2 times radical 2x minus 6 equals a negative 4. I'm now going to divide each side by 2. So I'm going to end up with radical 2x minus 6 equals a negative 2. The radical is isolated, so I'm now ready to get rid of it by squaring the left side, so I have to square the right side. Square rooting, and squaring cancel each other out, so I get 2x minus 6. And the negative 2 squared is a positive 4. All right, so I have a basic equation to solve. I'm going to add 6 to both sides and get 2x equals 10. I'm going to divide each side by 2 and get x is 5. I'm going to need to take that and plug it into the original to see if it works. Well, you go ahead and do that and pause the video and come back and let's see if we both have the right answer. All right, hopefully you realize that positive 5 does reject. Please remember, you're plugging him back into the original. So the left side did not equal 4 like the right side does, so you have to reject it. So again, here your answer is an empty set. 5, which is the last one we have to do today. Again, the radical is isolated, but it's not square rooting, it's fifth rooting. So in order to eliminate the fifth root, what you would do is raise each side to the 5th power. That's all. So, 5th rooting and raising to the 5th power cancel each other out, and I get 3x minus 1. 2 to the 5th power is 32. I'm going to add 1 to both sides to solve because I no longer have a radical, and I get 3x equals 33. I'm going to divide each side by 3. X is 11. I'm going to plug it into the original to see if it works. And I'm probably going to need my calculator in front of me. 3 times 11 is 33, minus 1 is 32. The 5th root of 32 is 2, so it works. And my answer is 11. So that's how you solve radical equations. And tomorrow we'll do a few more in class just to make sure you have the hang of it. Have a good evening.